In this last session, we're actually going to go back quite a long way when we were doing functions and we talked about the function of a function. Today, what we're going to do is we're going to look at how we can differentiate a function where in actual fact that function is a function of another function. The function rule is a rule that you are given. You are given the rule, and sometimes makes it easier if we actually do a substitution first. We would in any case need to rewrite the function as y equals x squared, x cubed, sorry, cubed, what am I talking about, to the power of a half, before we do anything. So what we're going to do is we're going to say let u equal the inside function. So let's u equals x cubed plus 4x. And now we can rewrite y as y equals the square root of u, or u to the power of a half. Now the chain rule tells us that dy by dx is going to be equal to dy by du, so the derivative of u to the half would be a half u to the negative a half times du by dx. And du by dx, x is u cubed plus 4x, so it would be times 3x squared plus 4. Now, we can't leave it like that. We need to replace the u with whatever it was, so it would be a half times. Now, u was x cubed plus 4x to the power of negative a half times 3x squared plus 4. Now, if you look at that, another way of actually sort of expressing this is that it's the derivative of the whole times the derivative of the inside function, or the derivative of the outer function times the derivative of the inside function. If I were to say, okay, let's talk about this. This is y equals something to the half. So the derivative would be a half times something to the power of a half minus 1, which is negative a half, times the derivative of that something, which is the third part here. So you can either do it explicitly using the chain rule, which you are given, or you can think of it as the derivative of the outside function times the derivative. So the derivative of the whole times the derivative of the inside function. Let's do it like that this time. So let's find the derivative. It's the derivative of the whole. The derivative of the whole. The derivative of the whole is cosine root x times the derivative of the inside function, and the inside function is root x, so the derivative of that would be a half x to the power of negative a half. And you could leave it like that if that's what the question was asking. The first one, if we rewrite it as 2 times cos alpha to the power of 5, then we can see that it's easier to do it that way. Then it's the 2 times the derivative of the whole, which is 5 cos alpha to the 4 times the derivative of what's inside, which is sine alpha. This one is your kind of inner function, so the derivative is going to be the derivative of the inside function, which is 2 times the 5 that's already there, times the rest. This one, the derivative is going to be the derivative of the inside over, and you'd have to play around with the fractions of this one, so it'll be 1/2 times x squared. What you've actually ended up with in there is some x, a bracket to the half and a bracket to the negative half, and do your multiplication and your division there. This is just a generalized way of looking at the derivative of a log function. We have done it before. We differentiate the bracket over the bracket, and if you've got an e to the function of x, then it's the derivative of the power times the original, just as we did before. Let's look at some of these and see which rules we have to use. For the first one, we would need to use the chain rule, so it would be 6 times 2x minus 1 to the power of 5 times the derivative of what's inside. Similarly, for the second one, it would be 5 times 2x cubed minus 5x to the power of 4 times 6x squared minus 5. That's an x. The next one, you would rewrite it with a negative power, and then you'd use the chain rule. Have a look at number 5, where it's an e function. Then it would be the derivative of the power, which is 6 squared, but it's multiplied by the 2 that's already there, and then times the original.